Hi, welcome to my tutorial on direct proportion. This is part 2. This one's a slightly more complicated one. You should already have watched part 1 before you move on to this one. Okay, this is the example we've got. P is directly proportional to the square of Q and P equals 6 when Q equals 4. Part A, write a formula for P in terms of Q. Now the first thing to notice about this is it says proportional to the square of Q. Please don't forget that. A lot of people miss that out and you will not get any marks for it in a GCSE exam because you haven't done the correct question. So if we write down our proportionality statement now, you've got P is proportional to the square of Q. So we write in there Q squared. Now we can put that into our equation. So P equals, and we introduce the constant K times Q squared. Now we can then put our values that are given for P and Q in the question. So P is 6 and Q is 4. So we can replace this. 6 equals, well this time Q is 4. So it's 4 squared times K. So we end up with 6 equals 16K. So if I now take the 16 over to the other side, K is going to equal 6 over 16. Now that simplifies to 3 over 8. So we can write down here K equals 3/8. Now all that's left to do is to replace our value for K that we've just found out into our formula. So P is equal to K, which is 3/8 multiplied by Q squared. Part 1. Remember, once we've got the formula, it's very easy to work out the other two parts of the question. Part A, find P when Q equals 5. So all we need to do now is replace Q with 5. So we get P equals 3/8 times 5 squared. Remember the squared, which is 25. So for this one, P is going to equal 3/8 times 25. And if you remember for part 1, I always like to put the 25 over 1 to make it simpler. Then I just multiply those together. So 3 times 25 gives me 75, and 8 times 1 gives me 8. So our answer for P is 75 over 8. If we want to write that now as a mixed number, 8 goes into 75 9 times. 9 8s are 72, so we've got 3 left over. So we end up with 9. P equals 9 and 3/8. And the last part here, find Q when P equals 9. Slightly harder. We've now got to go back to our original formula, and we've got to replace P with 9. So this time we get, that's what equals there, 9 equals 3/8 of Q squared. And if you remember from part 1, I told you if you've got 3 over 8, it's a lot easier to write that as 3Q squared over 8. So this is basically the same as saying 9 equals 3Q squared over 8. It's just a better way of writing that. Now it should be easier to see that we need to take the 8 up to the other side. So take the 8 up, we're dividing on that side, so we multiply on the other side. So that gives us 72 equals 3Q squared. And then finally from this stage we can take the 3, we're timesing the Q squared by 3 here, so we'll be dividing on the other side. So if I move down to here, you're going to get 72 divided by 3 is going to equal Q squared. And 72 divided by 3, well 3 into 72 goes 24 times, so we've got 24 equals q squared. But of course we don't want to find q squared, we want to find q. The opposite to squaring is square rooting. So if we take the square root of both sides, that's going to leave us with q equals the square root of 24.